The topic of this presentation is place value in decimals.
Due to the nature of our numeral system, decimal fractions are central to young students' early success in mathematics. Students are in contact with decimals in the real world in forms such as money, petrol prices, and temperature reading.
Students have difficulty transitioning from real-life concrete experiences to abstract notation. As teachers, we need to employ multiple teaching strategies to ensure that students can understand and process decimal fractions in multiple ways.
Students' conceptual understanding of decimals emerges from their whole number knowledge. Decimals are a special class of fractions with base 10 denominators that merge whole number knowledge with common fractions.
As students progress from early stage 1 to stage 4, they learn to represent decimal fractions in multiple ways to develop a conceptual understanding before performing operations.
Understanding misconceptions is an essential step in improving instruction in decimal fraction lessons. Misconceptions arise when students inappropriately apply rules that work with whole numbers to decimal fractions. This results in the right answer for the wrong reason.
A key misconception that arises from incomplete understandings is that longer decimals are larger, as they look at them as whole numbers without acknowledging place value. For example, students might read these numbers as 2,999 and 3.
Another common misconception is that decimals are less than 0 and negative numbers. This arises from students' incomplete understandings of place value with decimals, as they confuse the symmetric place value names around the ones column with the positive and negative parts of the number line, which are symmetric around 0.
You can use dynamic representations such as the zoomable number line, which allows you to illustrate that the length of a number is not indicative of its size, rather the place value determines it. Students can manipulate this resource to explore the density of the number system, as it can display tenths, hundredths, and thousandths.
A significant misconception common amongst students is that putting a 0 on the end of a decimal makes it 10 times larger. This arises from incorrectly applying their whole number knowledge to decimal fractions.
This whole number knowledge transfer is additionally evident in the misconception of students viewing decimal fractions as being composed of two whole numbers that are separated by a decorative dot.
To help students avoid or correct these misconceptions, teachers can introduce concrete manipulatives in tasks such as MAB blocks. This representation allows students to visualize different values of numbers in a decimal fraction according to their place value.
Students must have a conceptual understanding before they can perform operations, such as multiplying decimals in stage 4. This step beyond primary level highlights the importance of avoiding or correcting misconceptions regarding place value in decimals before performing written algorithms.
As future teachers, you must have multiple representations to support differentiation of students working towards outcomes and students working beyond.
Created using Powtoon.